Well, it's 7:06, but I want to go ahead and get started. You guys can talk about it during break. Okay, so today we're going to go over chapter 13. We still have one problem left and like a few more slides from chapter 12, so I'll go ahead and get started on that. And today's chapter 13 is the shortest lesson in the course, so we're going to have, I would say that I prepared a longer Kahoot to play because we're going to have a lot of time left over, and we're also going to go over some review problems from previous chapters. So, okay. So the problem that we left off at, it's a little bit more complicated, but we can go ahead and try the problem, and then I'll make sure to go over the problem afterwards.
Can you show us an image of the circle?
Yeah.
Here.
So it's kind of, whoa, that's so complicated.
Here.
All right, that's a really complicated one. Like, what? Play? No. Can. So this is our last class. Yeah. So the radius of the circle O is equal to 31. So and OP is equal to 40. So and P and the radius of P equals 708. And find XY. Right?
Can you go back to some previous points before this problem?
Yes. Okay. Let's see. We're going to. There are quite a few slides that we went back. Okay. Okay, how about we go over like the important information that we learned from the previous chapter, because we have a lot of time today, and then we'll go back to the problem.
So can I explain this?
You want to explain the problem, or?
I'll explain how this theory works.
Or I'll just go over everything really quick, and then we can go back to the problem.
So
okay.
Can I explain it?
We can just, how about you just listen, and then we'll just go back really quick. I mean, we have a lot of time today, but I just want to have enough time to go over chapter 13 and then review problems. And the Kahoot too. Okay, so the measure of an inscribed angle is 1/2 the measure of the arc it intercepts. And this is pretty straightforward. So PQR is going to be 1/2 of arc PR.
But only if it's an inscribed angle.
Yes.
If it's if the angle isn't like in the center, then the angle is equal to the arc.
So okay. So next, any two angles that are inscribed in the same exact arc are equal to each other. So for example, angle B and C are inscribed in arc AD, therefore angle B is going to be equal to angle C. So remember, an inscribed angle is when the ends of the angle and the vertex of the angle are touching the circumference of the circle. And in this case, both angles B and C, the ends are touching A and D, so they're going to be equal to each other. And okay, next, So the measure of an angle created by the intersection of two chords is the average of the measures of the arcs intersected by the chords. So for example, angle PTS is going to be equal to angle QTR, and that's going to be equal to arc PS plus arc QR divided by 2, or X plus Y divided by 2. So this is just basically finding the average of two different arcs that are intersected by chords. So it's not, it might sound complicated at first, but it's just finding the average. Okay. And then next, two secants meeting at a point that is outside of a circle form an angle that is equal to 1/2 the difference of the arcs that they intercept. So for example, angle Z is outside of the angle of the circle. So what you would make it equal to is B minus A. So B would be the larger arc, A is the smaller arc, divided by 2. Okay. And tangents, so remember that a tangent line is a line that intersects or touches, for example, in this case, let's say that, let's look at line M. Line M is tangent to circle O because it touches the circumference of the circle at exactly one point, and that one point is B. So a line that is tangent to a circle is perpendicular to the radius that is drawn to the tangent point. Additionally, a line that is drawn through a point on a circle that is perpendicular to the radius drawn to that point must be a tangent line. So for example, line BC is perpendicular to BO, which is going to be the radius. Remember, this is an abbreviation for if and only if. So line BC is perpendicular to BO if and only if line BC is tangent to circle O. Okay. Next, an angle that is formed by a tangent and a chord where the tangent point is an endpoint equals 1/2 the arc that is intercepted by the angle. So for example, line M is tangent to the circle at point A. Therefore, angle ZAB is going to be equal to arc AB divided by 2.
But the line M is only tangent to the circle if and only if angle A was 90 degrees.
Or it would be, yeah, perpendicular. So a line can be tangent to a circle, but in order for a line to be perpendicular to the radius of the circle, here, let's go back. So if we go back here, the difference is that we're looking at BO, which is the radius of the circle. It's not a chord, or I mean, it is a chord, but it's not a 90-degree chord. So because it's the radius that we're dealing with, and we're also dealing with line M, that's going to form a 90-degree angle, so that's going to be tangent. Line M has to be tangent to circle O in order for it to be perpendicular. So these are two different things. In this case, it's going to be perpendicular, while, where was it? Did I go too far? Is it this? Yeah, sorry. While in this case, for example, chord AB, it's not the radius, so obviously it's not going to form a 90-degree angle, but line M is still tangent to the circle. Okay. So more information about inscribed angles. An angle between a tangent and a chord is often called an inscribed angle, the same name used to identify an angle between two chords that share an endpoint. The measures of both types of angles equal 1/2 the measures of the arcs that they cut off.
Can you draw a picture of that, or give us a picture of that,
Let's see, angle.
or can I ask you what exactly is a chord?
So a chord, this is a chord. A chord is a line segment where the two endpoints of the segment touch the circumference of the circle.
Okay, so kind of like an arc, but except that, but it's straight.
Mm-hmm. Same maybe to identify. Let's see. Two tangent. Okay. So for example, an angle between a tangent and a chord, so that's often called an inscribed angle. So this is an example of also an inscribed angle because this is a chord right here, and this is a line. This is a tangent line, so therefore, angle ZAB, that could also be considered an inscribed angle. But then remember that you can also call, let's see, if we have an example. If you look at angle BAC right here, this is an inscribed angle because the endpoints of the angle and the vertex of the angle are touching the circle circumference. So those are two different types of angles, but they're still called inscribed angles. Okay. So next we have tangents, and we can draw two tangent segments to a circle from a point that is outside of the circle. These tangents that are formed are always equal to each other in length. So if we look at the image here, we have two tangents, tangent line or segment PA and then segment PB, and you can see that they're tangent because they're touching the circle exactly one point, and they're shooting out from point B or point P, so therefore these two segments are going to be equal to each other. Okay. And cyclic quadrilateral is a quadrilateral that can have a circle be drawn around it, and the circle must pass through all four of its vertices. This quadrilateral is said to be inscribed in the circle, and the opposite angles of any of these types of quadrilaterals add up to 180 degrees. Okay. So now that we've gone through review, we can go back to this problem, and then we can move on to chapter 13. Okay, I'll go ahead and go over this problem. So what you first want to do is, I'm not a good drawer, so I just have an image up here, but what you would do is draw XY, um, and then you would have radii to the points of tangency. So in this case, it would be OX and PY, and segment connecting the centers. So in this case, it would be OP. So we don't have a right triangle, but or we will eventually figure it out that we do. But we know that the radii OX and PY are perpendicular to tangent XY. So OX and PY are perpendicular to the same line, so this must mean that they are parallel. Remember that this is a sign that indicates that two segments, two lines, two rays, etc. are parallel to each other. So then what you can do next is you can make a right triangle and a rectangle as shown. So there's right triangle ZOP and rectangle XZPY. And then next, you can draw a line through P. So then that would, as a result, make ZP and XY parallel to each other. And ZX and PY are going to be equal to 7 because we know that the radius of circle P is equal to 7. So then OZ is going to be equal to OX minus ZX, and that's going to be 31 minus 7, and we would get 24. So then OP would be equal to 40, and you would use the Pythagorean theorem to find PZ. So then the equation that you would get would be PZ is equal to the square root of OP squared minus OZ squared, and you would plug in numbers, so you get 40 squared minus 24 squared, and that would be equal to 32. And since XYPZ is a, sorry, it should be a rectangle because it's obviously not a triangle. XY is going to be equal to ZP, which is going to be 32. So the length of the common tangent is going to be 32. Here, I'm going to fix that. Okay. I'll leave this up here for a few seconds and then we can go ahead and go over the last two slides. Okay. So next, we have more information. If the median's length of a triangle is 1/2 the side length to which it is drawn, then the triangle must be a right triangle. Additionally, the side to which this median is drawn is the right triangle's hypotenuse. So if you look here.
What does it really mean?
Okay, so you know what a median, okay, so median is a line segment that extends from.
You say what median means, just what it means, not median. You don't need to say what median means, just say what median.
All right, so okay, so you all know what a median is, I'm assuming. Okay, so if the median's length, let's just go over this again. If the median's length of a triangle is 1/2 the side length to which it is drawn. So let's take this triangle as an example. So let's say that this median was 1/2 of the side that it's drawn to, then that must mean that the this triangle overall, triangle NLM, should be a right triangle. But in this case, the median is longer than 1/2.
What does side length mean?
Side length, so this is a side length. This is a side length, that's side length. But so in this case, the median is drawn to NM, and if the median was 1/2 the length of NM, then triangle LNM would be a right triangle. But because the median is longer than 1/2 the length of NM, triangle LNM is not a right triangle. And additionally, the side to which this median drawn is the right triangle's hypotenuse. So this would be in this, if we were to say that, okay, we can just say that MLN is a right triangle, even though it's not. But let's just assume that. That means that the median, the side that the median is drawn to, that would be the longest side of the triangle or the hypotenuse. And this is just a side note, but you always want to look out for right triangles because they're pretty useful in problems. And you can also apply Pythagorean theorem so that you can find even more measures and lengths. And if the right triangle is a what?
So there's also some side notes.
Yes, but if you can also use 45, 45, 90-degree triangles or 30, 60, 90-degree triangles to figure out different side measures. So right triangles are quite handy. Okay. Next, the vertices lengths of triangle ABC to the tangent points of its incircle are given. Okay, so let's look at this image over here. So AZ is going to be equal to AY, and that's going to be S minus A. Let's see. Okay, next.
CD is equal to B.
Yeah. Yes, and that's going to be S minus B. And CS is going to be equal to C, it should be CX, sorry. Oh my gosh, I have some typos. Okay, CX is equal to CY, and that's going to be S minus C.
Can I ask a question?
Yes.
What does semi-perimeter mean?
Semi-perimeter is it's when you add up A plus B plus, so AB plus BC plus AC, and you divide it by 2. That's what the semi-perimeter.
So just like the whole circumference of anything.
So it would be the perimeter of for example,
divided by 2.
Yes,
So,
basically.
Thanks.
Yeah. So you would add up the perimeter of the, or you would find the perimeter of this triangle and then just divide it by 2. Pretty straightforward, I think. And yeah, so that's pretty much it for chapter 12. And we can go ahead and go to chapter 13.
Yeah. Okay.
Okay, so chapter 13, I'm pretty sure it only has 2 sections, but we're going to learn about the power of a point.
I thought we were playing Kahoot, and then no. Yeah.
We're gonna play Kahoot later. We will be playing Kahoot, but we're going to play it later. Okay, so first section, what is power of a point? Okay, so we're going to start this chapter out with a problem. Knowing that chords AB and CD meet at point X, show that XA times XB is equal to XC times XD. So this problem, you're supposed to do it so that you wouldn't have, like, you don't have a reference image, but I'll just give you one. let's see. Animate.
People just don't try to read the answers. Oh, by the way, I do see BTS Pinterest.
Okay. So let's go over this problem. So rearranging what we want to prove, it's going to give us xa divided by xc equal to xd over xb. So what you just did was, you just rearranged the original two ratios that we were given. So once we rearrange it like this, means that we should probably look for similar triangles. So then what you would do is you would draw AD and BC to form two different triangles. And angles B and D are inscribed in the same arc. So then that means that angle B is going to be equal to angle D. And angle AXD is going to be equal to angle CXB. So triangle AXD is similar to triangle CXB by angle-angle similarity. So XA divided by XC is going to be equal to XD divided by XB. Hence, XA times XB is equal to XC times XD.
Weird words. Weird words like hence. Yeah, really weird words. Really.
Okay, so here's more important information. Okay, so let's assume that a line that goes through point P intersects a circle at points U and V. So the power of a point theorem states the following. For all such lines, as described previously, the product PU times PV is constant, and this resulting product is the power of point P. So for example, we can apply the power of a point to this following image right here. So applying the power of a point to x with respect to this circle over here, that's going to give us xa times xb is going to be equal to xc times xd. Again, here's another example. In the figure below, the power of a point P with respect to the circle, it should say gives us the following. It's going to be PA squared is going to be equal to PB times PC, which is going to be equal to PD times PE. And we think about power of a point whenever we have a problem that involves a circle as well as intersecting segments. And of course, we're going to practice using power of a point because this concept might be a little bit weird in the beginning, but eventually it will make sense. Okay, so next we have problem 13.3. Chord TY and chord OP meet at point K so that TK equals 2, KY equals 16, and KP equals 2 times KO. Find the value of OP. And I'll just pull up
Where is the image? Oh, thanks.
Here.
So couldn't we say
equals
using the
to
point
K1
theorem,
and K.
PO equals TY?
So KP equals.
Using the point theorem, because they both meet at point K.
So can I say something here? Can I say something here?
Yes.
So all we need to figure out is okay. So because okay times 1.5 is equal okay times 1 times 3 is equal to OP. So we only need to find out okay, the value of okay.
I wanted to say, so because we can use the point theorem, PO equals one PO equals TY. And if TK plus KY equals 18, then PO should equal to TY. So OP should equal 18.
You're pretty close. That was a good mindset. I think you just mixed up some numbers.
No, P. So TY.
Okay. So using the power of a point to x with the respect to the circle, we have Kp times Ko is equal to Kt times Ky. So then if you substitute the information, you get 2 Ko times Ko, which is equal to 2 times 16. So as a result, you would get Ko is equal to 4. So then Kp would be equal to 2 Ko times 8, meaning that OP would be equal to Ko plus Kp, which is 12.
Still didn't quite get it.
Okay, so remember, let's go back to PowerPoint. So what you do when you have PowerPoint is you're going to look at, two different line segments, see where they intersect. So in this case, for example, AB and DC intersect at X. That's going to be your PowerPoint to X, and then you're going to set up basically two proportions. So you would multiply XA times XB, and then you're going to make that equal to XC times XD. So it's just taking the same segment, but then you can see that the segment gets split up into two different segments by the point, and you're just going to make multiply them, and then you do the same thing with the other line segment. So you see, oh, here's point X. Here is line segment AB. I'm going to multiply AX and XB, and then I'll do the same thing with this line. I'm going to multiply DX and XC. And of course, you make them equal to each other. Okay. So I will go ahead and go to the next problem. So in the diagram, CB is equal to 9, BA is equal to 11, and CE is equal to 18. Find the value of DE.
Okay, but we still needed to find DC. Yeah. Pretty hard work.
I just wanted to say that I remember in earlier notes it says that if two lines are connected by the same point, they are
Equal.
to each other. Oh, thank you.
But
So,
I think it means arc.
yeah, Alika has a pretty
But
good
this is
explanation.
My name is Alika.
Oh, Alika.
The problem is this has nothing to do with arc.
So what Alika said, probably CD equals 11.
You're
Not
close to
11.
the answer.
Not 11. 9.
AB over BC is equal to EC over ED over DC. So that means, wait, let's see. So I think AC over AB is equal to EC over ED.
You're pretty close. I like how you guys are setting up ratios.
For AC over BC is equal to EC over DC.
Okay, here, let me just pull up the answer. Okay, so because we have two intersecting secants, we can apply power of a point. So in this case, CD times CE is going to be equal to CB times CA. So if you were to plug numbers in, you get CD times 18 is equal to 9 times 20, meaning that CD is equal to 10 and DE would be CE minus CD. So then you would say 18 minus 10, and that would be equal to 8. I'll just leave us up here, and then we can move on to the next problem. Okay, so next we have 13.2, which is more about different problems that we would deal with by using power of a point. Okay, so next we have 13.6. Point Z is on circle O and secant XC hits the circle at point Y, so that XY is equal to 6 and YZ is equal to 5. Given that point X is 9 units from the center of the circle, find the area of this circle. And I'll
What does secant mean?
Secant line is when, for example, XC is secant to the circle because it passes through 2 points of the, it passes through the circle circumference twice.
Got it.
I would try putting the circle in a coordinate plane.
Okay, so I'll go ahead and go over the answer. So what you first want to do is start with this diagram. So next, what you want to do is you want to continue segment XO so that it would hit the circle again at V as shown. And now we can apply power of a point with respect to point X. So it would be XW times XV is equal to XY times XC. So now we're going to let the radius of the circle equal R, and we can substitute to get XO minus R times XO plus R, and we would get, we're going to set that equal to 6 times parentheses 6 plus 5. So since XO is equal to 9, that means that 9 minus R times 9 plus R is going to be equal to 66. So then from that, we can find the radius squared is equal to 15. So then that means that the area of the circle is going to be pi times radius squared, and that's going to be 15 pi. Okay. Oh, it's 7:46, so we can go ahead and take a 5-minute break, and we can come back at 7:51.
And then?
And then we'll do the rest of this lesson or this chapter, and then we can. This Kahoot is, I think it's on the longer side, but we can go ahead and play Kahoot, and then if we have some time left over, we can do review problems.
How many questions is this Kahoot?
It's like 14 questions, I think. But I think because last time when we played the Kahoot, it looks like some of you guys didn't have enough time to finish the problem. I just extended the time for some of the problems, so it might take longer, but you guys might finish the problems earlier than the amount or you might finish it within the amount of time that I give you. So it just depends on how fast you guys work on the Kahoot.
What's the code?
You mean the code for the Kahoot?
Yeah.
Well, I haven't started it yet, so
Oh.
yeah, we'll start it as soon as we finish this chapter.
It's frozen.
The screen is frozen.
Wait, my screen?
No.
Yes.
Okay, but you're not showing the...
Yes, it is break time. We have until 7:15.
A crash into Avanchan. Okay. Crash into Avanchan. Yeah. Oop. Yeah. Hi. Crash.
Is it break time?
Yeah, we have like 2 minutes left though.
What chapter is this Kahoot based on?
It's more in the like the beginning chapters, I think. I want to say it covers perimeter, area, angles. I can't remember exactly, but they cover more of the earlier chapters that we went over.
Are they as hard as the Kahoots before?
I think it's around the same level as the Kahoot that we played on Sunday.
No, those are really hard.
But we got there's more time, so if you can go figure out the problem, I think, because you won't feel like, oh, I have to figure this out in like 30 seconds or something. Okay, so it's 7:51, so I'll go ahead and start sharing my screen again. And we can go. Okay, we just did this one. Okay, we next have this one. So this is a two-part problem, but first we want to find BF and then we want to find ED. Okay, we can go ahead and go over the answers. So the first one is pretty straightforward. We can use power of a point to figure out BF. So what you would have done is FE times FB is equal to FA times FD. And then you would have isolated FB and you would have gotten FA times FD divided by FE. And you would plug in numbers, so you get 5 times 12 divided by 9, and you'd have gotten 20 divided by 3 as your final answer. For ED, using PowerPoint won't get us anywhere, but our proof of PowerPoint can get us the answer. So since angle FDE is equal to angle FBA and angle AFB is equal to angle EFD, triangle AFB is similar to triangle EFD. So that means that ED divided by BA is going to be EF divided by AF. So ED would be equal to EF times BA divided by AF, and that would be 9 times 10 divided by 5, and you would have gotten 18. I'll leave this up here for a few more seconds, then we can go on to the next problem. Okay. So YD bisects angle XYZ in the diagram, and you want to prove that XA is equal to ZB. Oh, there's no Z.
Where is Y and X in the
Hold on. I think I used the wrong image for problem 13.8. Hold on, okay. We can go back to this problem later here. I'll just, because I put in the wrong image. Oh, wait. Okay. We can just go over problem 13.9. I think 13.8 and 13.9 might use the same image, but I'll have to double check on that. Okay. Okay, so for problem 13.9, segment YD bisects angle XYZ in the diagram, and we want to prove that XA is equal to ZB. Okay, I just realized I accidentally typed out problem 13.9 twice, so problem 13.8 should have been a different problem. Whoops, it's okay. So this is basically what we were supposed to do for problem 13 for the first problem, but this is the correct image. Okay, we can go ahead and go over the problem. So this problem involves lengths and angle bisector, chord, secants, and circles. So we want to consider the angle bisector theorem and power of a point. And we can apply the angle bisector theorem, and we would apply it to the angle bisector YD of triangle XYZ, and that's going to give us XD divided by XY is going to be equal to ZD divided by XY. So then we would turn to power points X and Z, and that's going to give us XA times XY is equal to XD times XC, and ZD times ZX is equal to ZB times ZY. So then seeing the common terms in these two and the angle bisector theorem, we know we are on the right track. So then we can solve the two equations for XA and ZB, and we have the following. XA is equal to XD times XC divided by XY, and XB is equal to XD times XC divided by ZY. And we need to show that these expressions are equal, and we have ZX in both of these equations. So then we can say that XD divided by XY is equal to ZD divided by ZY from the angle bisector theorem. And if we put these together to show XA is equal to XD times XC divided by XY, and that's going to be equal to XC times XD divided by XY, that's going to be equal to XC times ZD divided by ZY, and that's going to be equal to ZD times XC divided by ZY, and that would be equal to ZB. So this one was kind of more the complicated side. So for those who are in middle school, I don't think that you're going to come across such a complicated problem too much. Maybe in
Yeah,
high
so
school.
I think it's
Uh,
less possible for
yeah,
me because I'm
where-
not even in middle school. I'm
Hey.
just in primary school.
Hey,
And I'm learning such complicated
Matt.
stuff.
I wanted to say that there's a course called 2-3. So there's either Common Core 2 or Common Core 3, which is high school. So we can do, there's an option of Common Core 2-3, which is basically a combination of those two, more advanced than both of them. So I think some of us may come along with this.
Yeah.
But this is just like complicated. This stuff is just complicated.
I don't think a lot of this like comes into like school standard math until about integrated 2 or so. For a Common Core system, it's like integrated 2.
Okay. We can go ahead and play Kahoot. If I can get I don't know how to get rid of this tab. I think it was right behind it. No, not what I want to do. Okay, there we go. Okay, so because this, okay, I know this is going to be a long one, but this Kahoot consists of a review, and then in case we have time left over, we can go over review. But this is probably going to be one of those times where we have such a long Kahoot because this chapter is really short, so that we can have more time to go over review of our problems, and then we can also review in a more fun way.
Gatling P3000 will destroy you all.
Are you sure? Kessler, you call yourself Kessler?
That's not me. I'm Gatling P3000, 2000.
There's
They're just imposters.
Keller.
Imposters, stop. You are not me. You are not me. The only person I am is Gatling P3000.
So, are we going to have a player named E again?
Okay.
Or
No, I think E is one of these imposters. E is one of this imposter.
so okay.
Wait, I didn't join yet.
Oh, you can. It's a pre-open. You can. It's like a rolling open.
Let's see. So, two supplementary.
4357938.
What? Don't know. Right. Two supplementary ratio. It's good for me. No. It is.
Okay. Nice.
None of you are real.
X is equal to
360 divided by 12.
yeah, 360. Oh, let me see. Nope. Yeah. Counselor.
None of you are real.
Yeah. What? What do you mean by none of us are real?
None of you Kesslers are real. You didn't
Yeah,
even spell
they
my
are
name right.
Kessler. You are the real Kessler. Yeah. He is the real Kessler. Okay. None of the answers are correct. I have no idea. And I never looked at talk of it. I never had any ideas. Ew. Guess where it's going down. Yeah. Ha! I got it.
The real Kessler would know this. What is my birthday?
But I just got it. Yes, I got it right. Got it.
The only thing the real Kessler would know is what is his favorite game.
Who is the real Kessler? Kessler, are you the real Kessler on there? Are you?
Find X.
I got it. I know what X is for. I got it.
The real Kessler would not be first.
I know which
The
one.
real Kessler would not be in first, but on the ranking position.
Let's share our ideas on the chat. I got this. I got this.
Okay, so type in the chat who do you think is the real Kessler? Out of real Kessler, Kessler number 2, and Kessler and Gatlin P1000.
None of real Kessler, Howie Bowie, Kessler number 1, Kessler number 2. They're not me. All of them. I'm not one of those players. Find X. Wait, I need my calculator. Mommy, where's my calculator? So I have to do it all by myself. So that makes 200.
This is very reassuring. Very reassuring.
100. So that makes 200. So 140.
The real Kessler is in 4th place.
I know the real Kessler in first place because the real Kessler is never in first place. So the first place real Kessler is fake.
There. Do you need to read it?
No, he just wants me to find a X, so there's nothing to say really.
What's the value of X? I think I know.
I think you know. Not.
Sorry.
I think you know not.
Can you max out? I want to see what are we supposed to. What is the value of X?
I know. No. Yeah.
I'm
Yeah.
still in 4th
Got
place.
it right. Got it right. Got it right. Oh my God.
I wonder who is the real Kessler, which is not Kessler. Like, I mean the nickname real Kessler, not like real as adjective and then Kessler.
Kessler, but not the real Kessler. Who's the real Kessler?
I wonder what is EFG.
EFG. So. Aha. No.
Real Kessler may have gotten this right.
Who is the real Kessler, but not the real Kessler?
The real Kessler is not the nickname, the real Kessler.
Yeah. But who's the real Kessler?
The real Kessler is still on the leaderboard and is not in 5th
Gatlin
place.
P. If you say real is an adjective.
Yeah, but we're not talking about grammar. Shh.
Is that 26 or 20?
26.
Okay.
You do know. Okay, the real Kessler has answered.
And the fake Kessler has, and the real Kessler has also answered.
The real Kessler, which is me. No, man. The real Kessler, which not the nickname, the real Kessler, me.
And the real
Kessler has already
Kessler has
answered.
also answered.
And each question has a 25% chance of being right.
With random guess, of course.
Yeah.
So I'm still in fourth place.
Because they're 4 choices. And each of them, if you had a random guess, you have a 25% chance of getting it right. Who just make that noise?
Who else? It is Alvin.
Just tell Alvin, can you tell your mom to shut up because we're having a class in English.
When you forget to cook the rice for mom.
What?
No, I'm talking about, I'm relating the countdown to when you forgot to cook the rice.
The rice.
When you forgot to cook the rice for mom and you only have 10 minutes left.
So yeah, but I never know how to cook rice. I only know how to cook spaghetti and stuff like that. Right?
For some reason, I'm still in fourth place.
The real Kessler, aka me, has answered.
You have answered. All right. The real Kessler, no, not the nickname. The real Kessler, which is me, has not answered. And still thinking, how are you supposed to do this?
Like you can say like the real Kessler has answered, but you can also say the real Kessler has not answered. And you're like, okay, then the real Kessler has or has not answered. You're like, well, whatever.
And it's just like you don't know how to answer because
The real Kessler, aka me, has answered.
Well,
The real Kessler had. Okay, did the real Kessler answer?
Yes, I just answered.
Okay, actually yes, because you answered now, no matter what, it's yes. Should have said that before.
all right.
What?
Why did it go to 0 and then we had
How
to
am I
count
still in fourth
from 10?
place? And
Yeah,
how
for
is
some
it-
How am I still the real Kessler?
My random guess cuz right again.
I think the cuz is not used here grammatically correct. It here is not used grammatically correct. Okay, good. It was.
Wait a minute. If each
Okay.
interior angle measures 108 degrees, isn't CAB still 100 degrees?
Sure, choose 108 degrees. You'll get it wrong.
I know.
Has the real Kessler answered?
No.
No, the answer is yes because I have answered already. Okay, I repeat. Has the real Kessler answered?
So the real Kessler is 17.
I don't know how I'm getting so real. Has the real Kessler answered?
Yeah. And besides, so easy because CDV is the only obtuse angle. So
Hurry, everybody, close your leave computer audio or mute your audio because he is about to say the answer. And now he's not. And that's why you can't say shape is a regular polygon if its sides are all equal. It has to be angles because if you do sides like this one, it's not a regular pentagon.
CXY in degree.
A, B, C, and P, Q are equilateral. What is the measure of CXY? What the heck, eh?
What do you mean? What do you mean?
Yeah, I said what the heck, eh?
Great though.
What do you mean?
When I'm starting to go
It
to
means
school,
what the
I'm
heck,
going
eh?
to be in the second grade.
Okay. How are we gonna do this?
Even if I go on Kane Academy, I wouldn't be
Gorilla.
able to do that.
Let the guessing begin.
Let the guessing commence.
Let's just skip
Let the
this
guessing
stuff.
commence.
45.
Okay, please don't tell me that something's gonna go crazy.
Come on, let's skip this.
You're already Coco.
Let the guessing commence.
Hey, I said this. Let the guessing
Well, it's called copyright.
copyright. You
Alright,
copied it first.
Because it's right again.
You copied it first.
L.
What is that? What is?
Okay, I'm gonna go crazy because I already found a way to find it, but I don't think I have enough time.
Can't you just guess?
I'm not
Why
guessing
are you going crazy?
because I know how to find the answer, but there's not enough time. Come on. Please. Oh! You guessers all got it wrong.
Wow.
Okay.
You guessers.
So for this one,
Never guess.
okay, so we know that these two triangles are equilateral triangles. So then the angles are all going to be 60 degrees. And we know that this is a line. So what you want to do is find angles ABC and YPQ first. So then you can find the angles YPB and YBP, and then this angle BYP is going to be, it's going to be, what do you call it? I can't remember. It's going to be a vertical angle of XYC. So then you can find, eventually you can find, yeah, CXY. So what you would have done is 65 plus 60, and then you would have subtracted that, and you first should have gotten, I believe, you would have gotten 55 over here, and then you would have done the same thing, so 75 plus 60, and then you would have subtracted 180 minus 60 plus 75, and you would have gotten 45. So then this is 55, this is 45. So then to find this final angle, you'd have done 180 minus 55 minus 45, and you would have gotten 80 degrees. So because you know that this angle is 80, this must mean that this angle over here is also 80 degrees. And you know that this angle over here is a 60-degree angle because this triangle is equilateral. So then you would have done 180 minus 80 plus 60, and that's going to equal 40 degrees.
Can I mention something?
Yes.
You don't actually have to find YBP and YPB. It just wastes time. You can just actually just find their sum. So basically, like C, because ABC is 60 degrees, you have this angle. I don't know how to represent it. CB something. It would be is the 135, and RP and YP something another letter on the line. Would be 135, and then you use 360 minus 125 minus 135 to get YBP plus YPB is 100. Then you can just find Y is angle BYP is 80. You don't have to like find YBP and YPB.
I didn't know what angles you were referring to, but I mean, it got you to the correct answer. So that just shows that there's more than one way to figure out the solution. But I don't know what angles you're referring to, Alvin, but it sounds like it's your conclusion is legit because you got the correct answer. So, okay.
So we got Howie Bowie Wowie. Then we got ew. And now we got the fake Kessler.
AKA the real Kessler.
The real Kessler is in 4th place.
Yeah, but the real Kessler is in 1st place.
Why are all imposters trying to be here just saying, I'm the Kessler? You're gonna end up like the real Fry.
Come on.
You're gonna end up like the real Fry from Fry.
Makes sense, but also doesn't make sense.
You.
So this sentence does make sense, but also doesn't make sense. The real Kessler is not the real Kessler.
My username was Gatling P2000. That's what I use for almost anything, except for my account, tree. And I see that BTS. Click the link. I want to see it.
It's just I think it's a picture of one of the members. I used to be a big fan, but now I'm not much of a big fan anymore. Okay, so next we have chapter 3 review problems. Yeah, okay. And we have like 6 minutes of class left, so we're just going to go through like just a few, and then we'll say class is over. Okay, so first you want to write the relevant triangle congruence and explain why the triangles are congruent. So is it like SAS, is it AAS, is it SSS, and then just explain why.
SSS.
Okay. Anybody else? All right, yes, Alvin is correct. Triangle ABC is congruent to triangle DCB by SSS. Okay, next.
Write the relevant triangle congruence and explain why the triangles are congruent. If they are not congruent, explain why.
I don't know if it's possible to say if they're congruent or not.
Because technically they're positioned in a way so that's almost impossible to figure out.
Yeah, they could be congruent or they could not, because this is SSA.
Yeah. All right. So SSA is not a valid congruence theorem. So that means that these pairs of triangles are not congruent.
They could be.
What is SSA again?
But there's SSA would be side-side angle.
Yeah, they could be though.
What? But
Well,
why?
I mean, we
Why
would need more
SSA
information.
SSA is not, but SAS.
Yeah, but where do you get SAS? There's no angle. You can't prove that angle E and angle H are the same.
Yeah. Okay. Next, we have this one.
Why did you move? I'm gonna go back.
Hmm?
Oh, thank you. Why is it SSA again?
That was
Can
my
anyone
Wait, no, that means parallel. Parallel, not equal. So AAS.
Yes,
Write
correct.
the relevant congruence and explain why the triangles are congruent. If they are not congruent, explain why. Couldn't SSA still not apply? We have
No, this one is AAS.
Yeah.
angle side side. Oh, angle side A.
So, because JK and MN are parallel to each other, angle K is going to be equal to angle M, and angle J is going to be equal to angle N. So
Those
that
aren't
means
those aren't straight lines. Those are arrows. Arrows mean they are parallel. So next time, can you make the arrows bigger? Because I think he thought that JK and MN were equal.
I mean, it's
I
the
didn't-
image that I used.
I never thought they were equal. I was just thinking that they did not list any angles or side. Oh, they only listed one
didn't
side.
get it?
They
Yeah.
did not. I know they were parallel.
Okay.
But because they're parallel doesn't mean they're the same size.
Now if they're parallel, then angle J equals angle N and angle K equals angle M, and then it says that JL equals NL, so it's AAS.
Okay.
Yeah. Okay. Next.
I call AAS. AAS.
I'm just, or yes. Yes. So because angle BCA is going to be equal to angle DC, angle ABC is equal to angle EDC, and AB is equal to ED, triangle BCA is congruent to triangle DC by AAS. Okay. Next, we want to find the isosceles triangle's vertex angle if one base angle is equal to 6 degrees less than half the vertex angle.
Is the vertex angle what's the vertex angle again?
Wait, say it again.
What is the vertex angle?
That's like the one angle that's at the top, or like it's the one angle that's not congruent to the other two. Like there's the one pair of two congruent angles, then there's the one angle that's like not congruent to those two. That's the vertex angle.
So if one base angle equals 6 then half the vertex angle, doesn't that mean the other base angle be? Doesn't that mean the other base angle would be the same as the one base angle?
93.
You are
What?
close.
Can you say that again?
96?
Yes, 96. Yeah, so let measure of the vertex angle equal x. That means, and then we can let each base angle equal x divided by 2 minus 6. So the three angles add up to 180, so we have the following. 6 plus 2 times x divided by 2 minus 6 is equal to 180, hence x equal to 96 degrees. Good job, Elika. Okay, so it is 8:30. So that means that class is officially over, and we will see you guys next time. Bye.
Bye.
Thanks for teaching.
Bye.
Bye.
Bye.